Okay guys, a lot of times you're going to be asked to reduce down to only sines and cosines. For a problem like this, I think it's probably necessary that we look at this and say, what could we do with each of these to make them in terms of sine and cosine before we even really do any adding or subtracting. So for this, I would say I know from your formulas that you have that tan x is actually equivalent to sine x over cosine x. Okay, that's one of those reciprocal formulas and identities that we have. And I know that cosecant is actually sine. So if I had cosecant squared x, it would be the same as having 1 over sine squared x. Likewise, if I had secant squared x, that would be equivalent to having 1 over cosine squared x. Okay, I know that you're trying to learn this on your own and you're trying to learn it as you go, and so maybe those things wouldn't strike you as extremely obvious, but telling you, kind of reminding you, I'm hoping this helps you ingrain that in your brain. What I'm going to do here is taking this into consideration. I know that tan is actually sine x over cosine x. Okay? I know that tan x is being divided by cosecant x because cosecant squared x is actually 1 over sine x. That means that I'm actually multiplying, when I divide, I'm actually multiplying by sine squared x over 1, or its reciprocal. Okay? So all of this is actually just that term right there. Plus, again, tan x is sine x over cosine x. And because I'm dividing by secant squared x, that means I'm multiplying by its reciprocal, which would be our cosine squared x over 1. Okay? So where this can help me, and again, I'm probably still going to have to do a little bit of additional work, but I wanted everything to be in terms of sine and cosines. Okay, so what I'm going to do now is simplify where I can. On this side, I'm going to end up with sine cubed x. That's what you get when you multiply. You add the exponents just like you normally would. And then cosine x on the bottom. And when I come over here, I'm going to be able to say, because these are being multiplied together, one of those cosines will take away one of those, and I'll have sine x cosine x. Okay, in general, we want to try to avoid having the denominator like that if we can. So my next step in this would likely be to go ahead and try to add those two together, and I would need to have a common denominator to do that. So I would go ahead and say over cosine x, and then I would be multiplying by cosine x one more time. All I'm doing is making this have a common denominator. Okay, and so from there I established the common denominator to be cosine x, and I can make this sine cubed x plus sine x cosine squared x. Okay? I want to always make sure that it's reduced down as far as I can get it. Okay, so for my next step, what I'm going to do is say I recognize that both of these have sine in common, which means I can take out sine x, and that would leave me with here sine squared x plus cosine squared x. All of that would be over cosine x. Anytime you have those squared, you want to check your Pythagorean formulas. Our Pythagorean identity says that if I have sine squared x plus cosine squared x, that's actually equal to 1. Meaning that all of this would actually be equal to 1. And I would end up with sine x over cosine x. Our directions were stated to leave it in terms of sine and cosine. Hopefully you recognize that means this could absolutely have been reduced down to tan x as one single form. So going through all of those steps, looking at every one of those simplifications, we did what we were asked here. We got it down to sine and cosine, but even still we were able to take it further if we wanted to.